Hello and welcome to the mathematics class. Now this is the third class of exercises. So in the last class we have discussed up to exercise 3.2, that was the last exercise of expansion. After this we will be starting factorization, but before we start factorization, three questions were left because we are moving in order as multiples of 3. So 30th question is left, 33 and 36. So I'll take up with the 30th question. Now in this it is given that x equal to 5 minus 2 root 6. You have to find the value of under root x plus 1 upon under root x. What we'll do, we know that x is equal to 5 minus 2 root 6. So we can say that 1 upon x can be written as 1 upon 5 minus 2 root 6. Since it is in the denominator irrational, so we will rationalize the denominator, means we will multiply by rationalizing factor or conjugate, that can be written as 5 plus 2 root 6. So we will multiply 5 plus 2 root 6 and at the same time 5 plus 2 root 6. This gives you 5 plus 2 root 6 upon a minus b. A plus b is a square minus b square, that is 5 square is 25. 2 2s are 4, 6 is 24. 25 minus 24, finally it will become 1. I am writing 25 minus 24 is equal to 5 plus 2 under root 6 upon 1, or finally it is 5 plus 2 under root 6. Now we need to find the value of root x plus 1 upon root x. We know that if I take root x plus 1 upon root x whole square can be written as a square plus b square plus 2ab. Root x square will be x. 1 upon root x square will be 1 upon x. This will be root x and 1 by root x cancel, plus 2. This is under root x plus 1 upon root x whole square. Now this x plus 1 upon x, this is x and this is 1 upon x. It means x plus 1 upon x. X is how much? 5 minus 2 root 6 plus 1 upon x is 5 plus 2 root 6. 5 plus 2 root 6 plus minus cancel, final value is 10. It means x plus 1 upon x, you are getting it as 10. So just place the value 10 plus 2, that is 12. It means root x plus 1 upon root x whole square is equal to 12. So root x plus 1 upon root x is equal to under root 12, taking square root both the side. So this square will cancel and this will become in root. So root 12 is 4 3 is 12, so it can be written as 2 root 3. So plus minus 2 root 3 is the value, but root x, this root x cannot be negative. It means we will skip this sign, or we will not consider this sign. So the final value is only 2 under root 3. That is the final value. Now we will be taking question number 33. Next, question number 33 is, if a square plus b square plus c square is equal to what? 25. ab plus bc plus ca is given as 50. You have to find a plus b plus c. So we have studied a formula, a plus b plus c whole square is equal to a square plus b square plus c square plus 2 times of ab plus bc plus ca. So this question is simple application of that formula. I am writing it. We know that a plus b plus c whole square is equal to a square plus b square plus c square plus 2 times of AB plus BC plus CA. Now you need to calculate this. You can see now a square plus b square plus c square. This is given as 125. Just substitute the value 125 plus 2 times of AB plus BC plus CA is 50. 50 into 200, 100 plus 125 is 225. Final value is 225. It means A plus B plus C will be under root of 225, and that we all know is 15. So that is the final value. This question was very easy. Just in this chapter you need to remember or learn or memorize all the formulae that you will be getting questions based on this in factorization also. So now I am moving on to question number 36. Then we move on to exercises that are based on factorization. Now question number 36, it's a statement problem, or it's a problem. It reads that if the number x is 3 less than a number y. So they say a number x is 3 less than the number y, means x is equal to y minus 3. First equation, a number x is 3 less than the number y. And second part, they say the sum of the squares of x and y. Sum of squares of x and y is 29. Sum of the squares of x and y is 29. You have to find the product of x and y. What is required to find? X into y you have to find. First of all, from this we can say that if x moves to this side, we can say that y minus x is equal to 3. Minus 3 came to this side, became positive. X moved to that side, became negative, like that. Now squaring both the sides, so y minus x whole square can be written as 3 square is 9. When you open it according to a minus b whole square, it can be a square plus b square minus 2ab is equal to 3 square is 9. X square plus y square is given to 29. So 29 minus 2xy or yx is equal to 9. This comes to the side. 29 minus 9 is equal to 2xy. In this you can say 20 is equal to 2xy. So 20 divided by 2 is equal to xy. That is 10 is the final value. Now we have finished all the questions of third chapter expansion. Now I will be taking up exercise 4.1, that was factorization. I will be moving in the multiples of 3 only. Now this is exercise 4.1, that is chapter factorization, and in this exercise 4.1 we have 9 questions, so we'll be doing in the multiples of 3. I'll be doing third question second part, 6th second part and 9th second part. Now in this we have already studied in factorization. I have taught you that this exercise is based on taking first, or basic thing is how to find common. So in this exercise we have to factorize the given expression by taking out common. Now let's concentrate on this. In this 18m plus 16n, what you can see as common? I think this 18 and 16 are divisible by 2. So if we take 2 common, 2 9s are 2 8s. It means we will take 2 common. We are left with 2 9s are 18 m plus 2 8s are 16 n. Final value, nothing can be done. That is all. Means you have to see, you have to find out which number or which expression or which thing, what is common in both. Maybe 2 terms are given, 3 terms, 4 terms, 5 terms, or whatever. Now we'll move on to question number 6, second part. It is 27a cube b cube, 27a cube b cube minus 18 a square b cube and plus 75 a cube b square. Now there are three terms given. 27, 18 and 75 are divisible by 3. 3 nines are, 3 nines are, 3 sixes are, and 3 25s. Now there is no common factor other than 3, means except 1 we leave it. So if we take 3 common from this, 3 common from this, 3 common, means 3 can be taken common from all these numbers. Now a cube, b cube, a square, b square, a cube, b square. So what can be taken common? At least a square, a square, a square, a square, b square, b square, b square. So what can we take common from this is 3 times of a square and b square. Now what is left? 3 nines are 27, a and b. Minus came, so we write minus. Now 3 6 are 18, a square already taken common, so nothing is left in a. Now b square, so it is b only left, plus 3 25s is 75, a is left, b square is already common, that is the final value. Now question number 9, second part. I hope this is very clear. Just you have to find out the common. So I'm not taking too many questions, just building up a concept that first of all, whenever you have been given a question to factorize, you need to find if is there anything common. If not, then we'll move on to the next steps. So first I'm taking one more question, that is 9th question, second part, that is x time x square plus y square minus z square plus y, it is minus x square minus y square plus z square minus z, it is x square plus y square minus z square. One thing you can see, x square plus y square minus z square. If you take minus common, this will also become x square plus y square minus z square, and here it's already x square plus y square minus z square. Means at least we can take this step, this term common by doing little bit or very small changes. So first thing, we will take minus common from this. So it will be x square plus y square minus z square. I am taking minus common. So plus y became minus y. This will become plus x square plus y square minus z square minus z, x square plus y square minus z square. Now everywhere you can see that this is common, so you can take this as common. It is x square plus y square minus z square. So what is left? X minus y minus z, that is the final value. So this finishes off with exercise 4.1. Now we move on to 4.2 and let's see what is there for us. Now in exercise 4.2 we have learned the second step. If there is nothing common, then we try or we factorize by making groups. Now in this question, in this exercise also we'll be taking in the multiples of 3. So third, 6, 9, 12 and so on with the second part. Now in this third question, second part, x cube minus 3x square plus x minus 3. In this we'll make group. So if from these you take x square common and here you can take 1 common. Means in first 2 I can take x square common. So what is left with me? X minus 3 plus. Nothing is common, but at least 1 is common in this. So I take 1 over here. What is left? X minus 3. Now in both these pairs we can take x minus 3 and x minus 3 common. So finally it can be written as, if I take x minus 3, it can be written as x square plus 1, and that is the final value. Now we'll be taking question number 6. In this you have to just make the pairs. Now look at the sixth one. Y square minus xy. Question is y square minus xy in bracket 1 minus x closed minus x cube. It is something like this. 1, 2, 3. 3 terms are there. If we open this bracket, it will become in 4 terms. So first of all, we'll try to convert this into 4 terms. That is, it can be written as y square minus xy. Xy into 1 is xy, minus and minus is plus. So plus xy into x is x square y. Then minus x cube. Now if we take from this, we can take y common. From this we can take x square common. If I take y common, what will be left? Y minus x. If here I take x square common, y minus x. Means in both the brackets we will be having the same thing. It means our procedure is right. So what I am doing, I am taking y common. What is left? Y minus x plus x square common. What is left? Y minus x. Now from both we can take y minus x common, and that is what we are left with, y plus x square. That is the final value. From here we took y common, so y minus x, y minus x. From here we took x square common, so y minus x, so y minus x. Now y minus x was common, so what is left? Y plus x square, y plus x square, that is the final value. Now question number 9, second part. Let's see. Ax plus by whole square. It is ax plus by whole square plus bx minus ay whole square. Bx minus ay whole square. Now we need to solve them. When you have studied about a plus b whole square and a minus b whole square, so we will open these, because in these two you can't find anything common except 1. So obviously we have to open it to find something common to make pairs. So when you open, this will become a square, that is ax, okay, a square plus b square plus 2ab. That was the first one about this one. Plus second one, a square plus b square minus 2ab. So that is bx square plus ay square minus 2 times of bx ay. When you open these brackets, this plus ay and minus 2bx ay plus 2 a b x y x y. So plus and minus will cancel. So this and this will cancel. Finally you will be left with a square x square plus b square y square plus b square x square plus a square y square. Now we can take from these two, we can take a square common. From these two we can take b square common. So in the first step, if I take a square common, I am left with x square plus y square. In the second, if I take plus b square common, I am left with x square plus y square. Now again, in both these terms we can take x square plus y square common. We are left with a square plus b square. That is the final value. Now we will be dealing with the, I think next question is question number 12. So we'll start with question number 12. Now in the 12th question, it is ax square minus bx square plus ay square minus by square plus az square minus bz square. This is very easy question. If you take ax square plus ay square and az square together and bx, by and bz together, you will simply get the value. From I am taking ax square plus ay square plus az square minus bx square minus by square minus bz square. Now a is common, so we will be getting x square plus y square plus z square. In the second this set we can take minus b common, so x square plus y square plus z square. Now we can take these two common, so x square plus y square plus z square and a minus b, that is the final value. This finishes your exercise 4.2. Now we'll be dealing with exercise 4.3, and in there also we'll be dealing in the multiples of 3, second part usually. In case you have any doubt in any of these exercises which we have done, please comment the exercise and question number so that I'll be discussing it, or I'll be giving you the solution separately or individually. That is the other method. Now in the third 4.3 it is a square minus b square is equal to a plus b and a minus b. This also we have studied, even in class 8 we have done, and in 9th also we have done. So I'll be dealing with questions for exercise 4.3. Now this exercise is based on difference of squares. So we know that a square minus b square is equal to a plus b and a minus b. This is what we are going to use. We will try to convert. Now look at the third question, second part. 9 3x plus y whole square. So 9 can be written as square of 3. It means this total portion can be written as 3x plus y whole square minus x square. Now it is in term of a square minus b square. Now this question has been converted into this form. So simply you can write a plus b and a minus b. So a is 3x plus y plus b. A plus b and 3x plus y minus b. That's it. If you want, you can expand it. This can be 3x plus 3y plus x. In the other bracket it will be 3x plus 3y minus x, can be written as 4x plus 3y, and here it can be written as 3 minus 1, that is 2x minus 3y, that is the final value. Now I will be taking question number 6, second part. Question number 6 is pi a to the power 5 minus pi cube ab square. Pi cube ab square. Now in this, first of all, we need to take something common. What you can say, pi. So pi common taken. A to the power 5. So a common taken. What is left? A to the power 4 minus pi square and b square. This can be written as pi a square whole square minus pi b square. Means this portion has been termed as a square minus b square, which can be written as a plus b and a minus b. So finally pi a, that was outside the bracket, and a square minus pi b, a minus b and a plus b, pi square plus, a square plus pi b. That is the final value. A square minus b square is written as a minus b, a plus b. That is the final value. Now we move on to question number 9, second part. Let's see what is there in this 9th question. It is a times a minus 1, a times a minus 1 and minus b times b minus 1. Now as you can see that there is nothing common in this. So what we'll do, we will just open the bracket or multiply the bracket or try to make it easy. Now this can be written as a square minus a minus b square plus b. If this and this is, now we are going to rearrange them. How? We will say a square minus b square, then minus a plus b. Now we know a square minus b square is a plus b and a minus b, so simply you can write it as a plus b and a minus b. Now from this term, if I take minus 1 common or simply minus common, I am taking minus common. So what is left? A minus b. This will become positive, this will become negative. Now a minus b and a minus b can be considered as common. So a minus b is common. So what is left now? A plus b minus 1, or final value is a minus b, a plus b minus 1. That is the final value. Now we'll move on to question number 12. In question number 12, I have taken the first part because this is a bit more complex as compared to the second part. In this, what we can do, a to the power 4, if I take minus common from the other three terms, 1, 2, 3, what will be left with me? B to the power 4 plus 1 minus 2b square. A to the power 4 can be written as a square whole square minus. If you look at this, a square plus b square minus 2ab, or this can be written as b square whole square plus 1 square minus 2 times of a, that is b square, and b, that is 1. So this is 2b square, 2b square, 1, 1, b to the power 4, b to the power. It means finally it can be written as b square minus 1 whole square. This is expansion of a minus b whole square. A square plus b square minus 2ab, and this is a square whole square. Now you know that a square minus b square is a plus b and a minus b. So this can be written as a square plus b square minus 1, and it can be written as a square minus b square minus 1. When you open the bracket or when you solve everything, you will be getting a square plus b square minus 1 and a square minus b square plus 1. That is the final value. Now we will move on to question number 15. Stop. Now 15th question, second part. 4x square minus y square minus 3xy plus 2x minus 2y. 1, 2, 3, 4, 5. Now in this question you can see there are 5 terms. So we cannot make the pairs. So first of all we will try to break them. It means if 4x square can be written as x square and 3x square. So we will break it as x square minus y square plus 3x square minus 3xy plus 2x minus 2y. What we did, since 1, 2, 3, 4, 5, this expression was of 5 terms. So we cannot make the pairs. So we tried to break any one of them that is possible. So 4x square, if I break it into x square plus 3x square, that one of the x square is expressed here and other 3x square is here. Now if in this we know a square minus b square is a plus b and a minus b. This finished off plus. From this if we take 3x common, we are left with x minus y. And in the next if we take 2 common, we are again left with x minus y. Means 1 common, 2 common and the third common. So simply we will take x minus y common, and whatever is left, x plus y plus 3x plus 2, that is the final value. Now last question, that is question number 18. I will be taking it up, and that after that I will be finishing. The rest, exercise 4.4 and 4.5 will be discussed in the next class. Okay, now this question number 18 is the last question, the last solution of this class. And this I have taken second part and third part. The question reads, express each of the following as a difference of 2 square. It means you have to find out a and b and write it in the form of a square minus b square. That is equal to, means in this question it has been given in a plus b and a minus b form. You have to write it in this form, reciprocate. Now in this, if you look at this, I think this can be considered as a plus b a minus b. So simply you can write x square minus 5x whole square minus 7 square. This as a and this as b. A and b. So a plus b, a minus b is what? A square minus b square. That's it. Now in this question, in the third part, it is x square plus 5x minus 7 and x square minus 5x plus 7. Now what we can do, this can be written as x square plus, I am taking plus common, so what is left? 5x minus 7. And in the second one I am taking x square minus common, so what is left? 5x minus 7. Now you can easily make out that this can be considered as a and this can be considered as b. So a square plus a plus b and a minus b is what? A square. A square means x square whole square minus 5x minus 7 whole square, that has been expressed in the form of a square minus b square. Now this finishes your exercise 4.3, 4.4 and 4.5 are left. I'll be coming up with the next class with the questions of those exercises. I expect everybody to practice, and in case you have any doubt, you comment in the comment box and let me know what is your problem. I'll try to solve it for you. I would like you all to please subscribe and like and share. Thank you.